Welcome to Your Space Journey, where we venture into the future of space exploration and the incredible leaders who are taking us there. Here's your host, Chuck Fields.
Hello, thanks so much for joining me today. This has been an exciting summer for space exploration. Just a few short days ago, we witnessed the incredible hop of Starship by SpaceX. This is very historic. I mean, first of all, who thought that silos could fly, which is incredible. But just down the road, a few years, this Starship is capable of flying up to 100 people to the moon and to Mars. That will be just incredible. Also, we just witnessed last week the incredible splashdown of astronauts Bob and Doug, who went aboard SpaceX's Crew Dragon for this historic mission as well. And then, of course, we saw the launch of Mars Perseverance on its 7-month journey now to land on the surface of Mars in February of 2021. But again, we're happy to return to our Around the World in Space series because, again, it's not just about what happens here in America, but around the world as well. And today we're going to focus on the European Space Agency, or ESA. Now, they just had a historic moment a few weeks ago, too. Their solar orbiter mission, launched earlier this year, just made a close approach to the sun and returned some incredible close-up images with high-res images of what sort of resemble campfires on the sun. Here's a clip from their recent press conference where they fortunately took a question from yours truly asking about this amazing images being returned from Solar Orbiter.
So we have a question from See Your Space Journey, which is a US podcast, and the journalist is Chuck Fields. Hello, Chuck. And the first question he has is, what is the approximate size of each of the campfires in today's images? When Solar Orbiter makes its closest approach to the sun at 42 million kilometers, how much smaller campfire features will it be able to resolve in size compared to the images released today? So I think, David, would you like to take this question?
Yeah, sure. The campfires that we see today are the smallest ones are a couple of our pixels. A pixel corresponds to 400 kilometers, the spatial resolution. So it's about the size of a European country, say. That's the size of the smallest campfires. The thing with the solar corona is that it's scale invariant. So if you look at smaller scales, you see smaller stuff. So I'm expecting that as we go closer, make our images better, get high resolution, that we will see yet smaller ones.
Wow, those images from Solar Orbiter are incredible. We'll have more on that later in the episode, as well as some other amazing accomplishments from ESA. But before we get to that, I'd like to share the story of my friend, Lane August.
Hi, I'm Lane August with Alpha Control, a Lost in Space podcast. Well, you know, watching Neil Armstrong take that first small step for man on the moon, that also led to me really enjoying those classic early TV science fiction shows like Lost in Space and Star Trek, but and being a fan of those shows, of course, I always thought as a kid, wow, it'd be so cool to go up into space. But since I regularly do these long-haul 12 to 16-hour international flights, I've discovered that my endurance for being confined in a small aluminum tube has its limit. So I'm afraid that for me to get up in space, one of two things is going to have to happen. They're either going to have to make those spaceships a heck of a lot larger, because I need some room to run if I'm going to be up there for days, weeks, or years. Or two, we're really going to have to do something about developing warp speed or a hyperdrive or a Stargate, because I don't think I could make it to the moon, Mars, not even to mention Alpha Centauri, until we get something like that going. So let's work on that now.
Your Space Journey.
Wow, thanks, Lane, for sharing your story. And folks, we'd love to hear your space story. If you'd like to send it to us, just email it. Email a video or audio clip to us at info@yourspacetourney.com. Or if you'd like to just leave us a voicemail, call us at 1-317-862 4700. We look forward to sharing your story. Please keep it to 2 minutes or less. We'd appreciate that. Now on to Issa. I had a great time speaking with Günther Hasinger. Günther is the Director of Science for the European Space Agency. He was born in Germany and earned his PhD in astronomy, later becoming a professor, researcher, and author. He is the author of an award-winning book called Astronomy's Limitless Journey, a guide to understanding the universe, and the winner of the Wilhelm Foerster Prize for public dissemination of science. Günther joins us today to talk about ESA and the incredible missions coming up, including Exomars.
Your space journey.
Hello, Günther. Thank you for joining me today. Really appreciate that.
Hello, I'm very happy to be with you as well.
Well, it is an honor. Now, I'd love to hear what fascinates you about space. Can you share how your interest in space began?
When I was finishing school, I didn't really know what I wanted to do. And I was playing in a band at that time, and we were in a studio taking a record. And at some point, my mother said, if you don't register at university, I will lose my child care benefit. So I went to university and I registered in the only place that I was interested in and that actually I could get onto, and that was physics. Originally, my career plans were completely different, medicine or biochemistry. But in the end, I ended up in physics more or less by chance. And I also didn't really, because I was playing in the band and I also did all the repairs of our amplifiers and stuff like that. I was more interested in electronics and getting my hands dirty. But then through one of the practical exercises, I ended up in the university observatory. I spent the summer there and I got all excited about observing the sky. And in the end, I think that caught me to live at the University Observatory, to work at night, to stay up to sleep during the day. So that slowly got me into astronomy.
That's incredible. I love that too. I love how a lot of people who get into space, they actually have a strong interest in music as well. So that's fascinating.
Yeah, that's also true. Not only space. I mean, a lot of physicists out there are also music fans.
I think that's amazing. Now, you had, just even so far, you've had this incredible career serving as a professor, researcher, director. Can you briefly describe how you became ESA's Director of Science?
Yeah, so I started my career in Munich, as I said, and I was actually for a long time, I was hooked up to the Max Planck Institute for Extraterrestrial Physics, where we are dealing with stuff from outer space. So that was where I came into space science. Then I became professor and director of the Institute for Astrophysics in Potsdam, the Leibniz Institute for Astrophysics. And then after I went back to Munich and I became the successor of my boss. So I became a Max Planck director. And usually the Max Planck Society is really, extremely well renowned and so on. So a Max Planck director is roughly the end of your career. But it didn't stop with that, because then I got very excited to move to Hawaii. And I became the director of the observatories in Hawaii, of the mountain observatories. And it's one of the largest collection of observing glass there, and it was a very large responsibility. And there I stayed about 10 years. But then both my wife and myself, we felt a little bit lonely there. Also, the family grew. We got a granddaughter. And so we wanted to move back to Europe. And so the opportunity to apply for the ESA director position was really just a marriage in heaven. So it's the best job that I had so far.
That is wonderful. Can you tell our audience just a little bit more about ESA's Science Directorate?
Yes, so ESA is a very big organization similar to NASA. It's more or less the European counterpart of NASA. And the Science Directorate is roughly about 10% of all of ESA. But I believe it's one of the founding parts. So the founding parts of ESA were actually the launchers and the science program. And it is a community-driven program. So all the member states have to pay in. It's a more or less mandatory fee that they have to contribute. But then the program is completely driven by the community, by the science community in the member states. we are putting out announcements of opportunity, and then the best ideas win. And we usually try to balance the program so that we cover all different fields of science. And there are huge, very legacy missions like Rosetta, for instance, or Giotto. The Hubble Space Telescope is part of ESA. We are a minor partner there. And so there are a lot of really very exciting missions over a broad portfolio.
See, I think that's wonderful. I want to talk about those amazing successful missions so far from ESA. You mentioned the Rosetta probe, which our audience may know it famously explored a comet. And then, of course, most recently, Solar Orbiter, which launched just in February to study the sun. And then Cheops, which is searching for exoplanets. First of all, I want to say congratulations to you and ESA for these amazing accomplishments.
No, thank you very much. And maybe I could also mention BepiColumbo that we launched about 2 years ago. And that is on its way to Mercury and has actually visited us around the Earth around Easter this year. This was in the middle of the COVID crisis, and it was very nice to see BepiColumbo look down on the Earth, and we are looking up, all kind of being together in this mess.
That is true, but you responded well to this mess that we have, because the Solar Orbiter is certainly just a remarkable result of that. I'd love to chat about that for a little bit.
Yes.
Recently, I understand it recently made its first close approach to the sun. It even crossed through the tail of Comet Atlas. Can you tell us more about that? That's incredible.
Yes, that was actually a fun story. So it was only about 6 or 7 times that a spacecraft flew through the tail of a comet. And in all the other cases, it was actually only recognized after the fact. But there is actually a group, very active a group of comet researchers that came out of the Rosetta project. They are very actively following up on comet research, and they have actually recently won a new project called Comet Interceptor. That is a new flexible mission, which we try to produce on a fast track, which is actually basically planned to fly directly through a comet, ideally through the coma, not even the tail. And it will actually split off 2 small satellites, and so that you can actually then measure that or observe that comet from 3 different directions. Now, the lead of this team, Gerard Jones, has realized that actually Solar Orbiter will also fly through the tail of Comet Atlas. And that was the first time that this has actually been predicted to happen. And so the excitement was really growing. Now, unfortunately, Comet Atlas itself has a life of its own. So shortly before the event happened, the comet is actually disintegrated into 25 different pieces. And by the time a Solar Orbiter arrived at the tails, it was already pretty wimpy. It was not really a comet anymore, just a debris pile of. Nevertheless, I think, we are still downloading the data and we are analyzing it. It is still not completely out of the question that we have seen some signals. So it's still exciting, and definitely it gives us a kind of glimpse what Comet Interceptor will later do.
That is incredible. Now, as far as the Solar Orbiter goes, obviously it made its closest approach first, but what can we expect next? What's coming up for the orbiter?
So indeed, I think we have now had our first perihelion. We did the first observations, which were basically twice as close to the sun than any other picture taken. And it is still not completely competing with the ground-based images of this Daniel K. Inouye Solar Telescope, which is a 4-meter ground-based telescope and has extremely sharp images, but only in the wavelengths that are allowed through the atmosphere. So Solar Orbiter will actually observe in many different wavelengths, in particular also in the extreme ultraviolet, in the X-rays, where there is a lot of excitement.
That is incredible. I do want to ask this. Of all the current and future amazing missions planned for ESA, is there any particular mission that just stands out to you personally that you're most excited about?
I'm a guy who is studying black holes, and I'm an X-ray astronomer. I've spent a lot of my career trying to understand what black holes are and why they are there and why they are growing. And also, I'm an X-ray observer, so I'm really looking forward to the next big X-ray telescope, Athena. But what really gets me excited is the gravitational wave telescope ESA, which is will measure the gravitational waves from merging black holes, merging supermassive black holes, and actually even more to measure together with between the X-ray telescope Athena and the gravitational wave telescope LISA. And that's what I call bringing sound to the cosmic movies. Because so far we see movies, but the sound is coming through the gravitational waves. And this combination, unfortunately, will fly in more than 10 years from now. So I will be retired by that time. But all my grandchildren and everybody else in the young age, they can really be excited about it.
You'll be able to enjoy it and just relax and not have to do any work. That's
yes.
Good. Well, there's a mission coming up that you won't be retired for. It's the Exomars mission, expected to launch in 2022.
Yes.
Now, I understand that actually consists of two missions, the orbiter, which launched in 2016, and then the rover planned for 2022. Can you give our audience just a general overview of the Exomars program?
Yes, so the Exomars indeed is consisting of these two different elements. The Exomars Trace Gas Orbiter, TGO, is actually flying very successfully since quite some time and is currently doing science. It is looking for trace gases on Mars, like, for instance, methane and CO2 and other things. And it has recently discovered, first time, the green glow. So, Mars is red, but we now have seen green light from the oxygen atoms in the atmosphere of Mars. Now, TGO is also a relay, a radar or radio link relay station. So it is also transmitting the data from the Mars rovers to Earth. And it is already currently transmitting about 50 to 60% of also from the NASA rovers to Earth. And so it was also an infrastructure element necessary for when we bring our own Mars rover, Exomars RSP or rover, which is now called the Franklin rover. When we bring that to Mars, we need the TGO in order to basically transmit the data. And originally, I think that the project unfortunately had several delays. Originally it was supposed to launch 2018, then 2020. Now we are aiming for the 22 launch, September 22. And itself will have a very powerful, the rover will have a very powerful chemical laboratory. It will drill into the soil. It can analyze the probes. It can look for molecule signs of life and so on. So that itself will be extremely interesting.
See, I love that because, again, I think that is one of the main goals of ExoMars, at least the rover, is helping understand and address the question of whether life has ever existed on Mars. And you mentioned the rover itself, and it's been named, as you said, Rosalind Franklin. That's the prominent scientist behind the discovery of the structure of DNA, which I think is fascinating and what an honor. You mentioned some of the details on the rover, including the drill. Can you tell us a little bit more about the details of the rover and the service platform?
So basically, the drill is able to drill in 2 meters deep, and the rover will be the first European rover. Let's keep fingers crossed because, it's very difficult to land on Mars. We have already left some debris there, unfortunately, but even NASA has their challenges, and so it's really one of the biggest challenges technologically. So let's hope that it will land safely. Then it can actually go 3 meters an hour roughly on Mars. So it can, it's not very fast, but it can actually, in particular, it's very intelligent. It can overcome all kinds of obstacles. We have new technology so that even if it kind of drills itself into the sand, we have a new technology that it can actually get out of all kinds of difficult situations. And we have in total 4 modules, different types of instrument modules on the rover. Then there will also be the instruments on the Russian landing platform, and so it will be very exciting.
That is exciting. Now, how will it land on Mars? I assume it's using a parachute system. Can you tell us more about that?
Yes, it is actually using a system of very complex system of parachutes. Unfortunately, Mars has enough atmosphere that you can land on Mars. Actually, maybe to look back, it was already interesting how we got the orbiter onto Mars. You know that, I mean, when you fly something to Mars, you have to give it a lot of push to get there, but then you need to brake so that you don't shoot by and land in the sun. So you actually have to, and the Mars, the TGO satellite itself is so heavy that you can actually not really use landing rockets or something like that or you would need to carry a lot of fuel in order to push and brake with the rocket. So we have actually used the aerobraking technique. We were using the Mars atmosphere while the orbiter was kind of flying around Mars. First in a very elongated elliptical orbit, it got more and more circularized, and then finally, this is something you can only do on Mars because the atmosphere is thick enough. And indeed, then also if you have enough sized parachutes, then you can actually land. Now we had some problems with the tests of those parachutes because to fold them is extremely intricate. It's very, very difficult. It takes, months to really fold them accurately. And in the first tests, the pouches in which they were folded were actually ripping apart. And because they have to unfold within a second, basically, very quickly. So you have to get them out. And so last year we have done some ground-based tests in the US where we were successful to actually get them out of the pouch intact without any damages. But actually the real test which is still missing and which will hopefully happen in October this year is the high altitude drop test. The next one, the first one did not succeed. I think the next one in October this year hopefully will succeed, and then we will be able to land safely on Mars.
Günther, that is amazing because I imagine there's so much testing that goes into this. And of course, you mentioned the atmosphere of Mars. And I just think Mars in general, it's amazing. The temperature can get down to negative 120 degrees Celsius. It's only 1/100th the Earth's atmospheric pressure, and it has a carbon dioxide rich atmosphere. Can you just tell us more about the testing involved to prepare the rover for this extreme Martian environment?
So I think it is, I mean, in principle, it's similar to other space projects. I mean, the temperature gradients are huge also for other missions. I mean, in that sense, the temperature is not that dramatically different. And we have simulation chambers where you can actually simulate the cold and the hot phase. Because the problem is it's minus 120 degrees in the shadow, but when you are in the sun, and it's getting warmer. But we have done the same for BepiColumbo, for instance, which is going to a 450 degrees environment. And solar orbiter itself is also extremely hot. So I think the challenge is the difference between cold and hot, the huge temperature range. And that is something where we have these test chambers, and we are really specialists in the so-called thermal control, where we keep things at a reasonable temperature. The carbon dioxide, the composition of the atmosphere is not such a big issue because in principle the atmospheric pressure is very low, so it doesn't really, it could be that carbon dioxide could affect the materials somewhat. It's a little bit also the acidity, whether it is humid or something like that. But this is not such a big problem.
That's wonderful. Günther, I want to talk more about you, if I may. You had this amazing career in physics and astronomy and space exploration. There's many folks out there that are getting really excited about just space exploration in general, and they want to get into that as a career. What advice would you offer them?
So one advice is basically, or two advices. First, just follow your instincts. Do not predetermine too much years ahead. Also, when you work in space science, the first thing that you have to learn is patience, because everything takes oodles much longer than you would like it to take. And so these projects, we are looking at years preparation. from the beginning to the end. It's almost a whole career. And so you cannot focus on one project and say, this is what I want to do. You have to be a bit opportunistic, follow your instincts, follow where the wind blows, but always shoot a bit higher than what you are actually confident with. So if you want to get a job as a researcher, aim to become a professor, for instance, or just shoot high enough, because the competition is quite strong, fortunately. But also, the opportunities are so many, and in the end, we will be brain limited and not kid limited. So we need all the young brains, and in particular, also we need to increase diversity. So people from diverse backgrounds, we are really very, very welcome in order to get 100% of the brain power that we need for the future.
That's wonderful. So literally aim for the stars.
Yes.
I love that. I love that. Now, Günther, you've also written an amazing award-winning book. The English version is called Astronomy's Limitless Journey, A Guide to Understanding the Universe. Can you tell our audience more about your book?
Yes. So actually, I started that book when I was still a professor in Germany, and I gave a lot of public talks. And after many of these talks, I think there must have been 1,000 talks or something like that over my career. After many of these talks, people came to me and said, "Where can I read this up that you are that you have said?" And I've read a lot of books. My whole early career, I was Carl Sagan and many of the other books that got me excited. And so I could only point back to those books when my readers or my audience asked me where can they read this up. And so then in the end, I decided just to write the talk down that I gave in order to give my audience something to read back up. But that then developed into a whole basically story from the beginning to the end, and even a little bit before and a little bit after. And so that then became, indeed, in 2008, it won an award of the best science book of the year in Germany. And when I moved to Hawaii, I always had the dream that I translate that to English. So I basically rewrote it. I updated it, I translated it. And so the new version that came out 2015 has now much more content about. But I think I soon need to write a new book because the development is so fast. Our knowledge increases exponentially, but also with every new discovery that you make, there are all of a sudden 10 new doors that you don't understand yet. So our ignorance is growing faster than our knowledge, and so we are getting more and more to work about.
That's wonderful. Well, Günther, I just want to thank you for sharing your story. Thank you so much for talking to us about ESA and the amazing missions coming up. Just again, thank you for your time today. Danke, Günther.
Thank you, soon. Thank you very much. Have a great day.
Your space journey.
Wow, I really enjoyed my conversation with Günther, and we are so excited about ESA and their upcoming and current missions, including Solar Orbiter, and we cannot wait for ExoMars in a couple of years. Definitely excited about that. If you'd like to learn more about them, just go to their website at esa.int. I want to thank Günther for joining us today. I want to thank you for joining us as well. We're going to continue our Around the World series in a couple weeks with our next episode on the Canadian Space Agency. So I'd like to encourage you to subscribe so you don't miss these exciting episodes. We'd also appreciate it if you'd share the episode with a friend. At any rate, I want to thank you for joining us today. We'll see you next time. God bless.